Thank you so much. I'll try to cover up on time. So that sort of leaves me with about 25 minutes. Uh, Hello, everyone. I know it's a sort of a SRE focused conference, and I'm going to speak about APIs and how do you break them up. I'll try to correlate them to how the SRE world sort of evolves with this change. I'll try to do my best. Uh, Quickly about me, I think Mr. Murthy spoke a lot. I don't need to say more. The only thing that I want to put it is positioning what I am doing so that you can get the context, because I'll give you a couple of case studies in terms of what we have done and how you could sort of replicate it in your own organization, right? So my role is sort of heading the platform engineering. We basically build platforms and solutions for consumptions within the organization. So 16,000 developers of Amadeus use our services to build their products for their customers. So what's Amadeus? Why I want to put this again? Again, it's not a sales pitch. We are completely non-related company. I just wanted to show the scale in terms of saying how complex it is to do for Amadeus. Amadeus is one of the early sort of a marketplace kind of a company which Amazon is known for today. But we were doing it much before Amazon was, but for the travel industry. So if you have ever traveled on a flight, you would have used our services, but you would not have seen it, right? So it's a B2B company. It has one of the largest data centers in Europe. So which means building applications is very complex. Transforming it is very complex. And like in the industry, every time you get onto a plane, you want to ensure that your plane takes off on time. You have the right seat, your baggage reaches on time. A lot of these things have to happen, keeping the technology side of it. So it needs to be 100% stable. So with all this, Amadeus was a huge monolithic application. And sort of a couple of case studies within which I'm going to cover in terms of how do you break them into smaller microservices, which it's easier to manage, right? So a little bit of Amadeus before I go into the context. So how have these evolved, right? So what I mean by a monolithic application, how would it interact with each other? Simple example of going back to my own example in Amadeus or maybe in the retail industry with Tesco and Walmart. The bit was they were one large application interacting between one application of any of these organizations with some other company's product or even their own company's product, which has been built, developed at a different time frame, was typically through TT5 messages or an EDIFACT messages. I mean, in the travel industry, it has been sort of a TT5 messages. That evolved from there on to a monolithic application, but still broken down, but sort of SOA-based applications, which is sort of working with each other via APIs, right? This could be within the organization again and external to the organization. And when I say internal to the organization, it could be team A versus team B, two applications built. Could be, let's say, the front-end application with the back-end application, could be with the warehousing systems, with the supply chain system, etc. Right? So how the interactions happened, again, in this evolution, it's sort of extending from the TT5 and EDIFACT, SOAP messages and REST messages sort of came in, right? And obviously, it's sort of moving in the cloud to microservices. In some cases, it's like independent systems. They don't even need to talk to each other. Really serverless kind of a application aspect, right? So there has been dramatic change in terms of the ecosystem in the way software has been built, right? But what has changed dramatically and is the way each applications talk to each other, right? So that sort of changed to the API model quite heavily. So stepping back a little, what do we mean by a monolith? I think this is where sort of the SRE bit sort of comes in. Monolithic application could be a huge code base, right? There is millions of lines of code built, deployed in one go. It's all sitting together, maybe sitting on a single server or a VM, and everything operates within that monolith, right? So that could be one. Second is there could be multiple applications, but the backend database is the same. So the agility of the whole application or any of these applications follows the slowest mover, which is the database. So it sort of makes it a monolith. The third could be a build. Again, when I said this is where the SRE sort of comes in, is the way an application is built, packaged, deployed, maintained, etc. Right? So in the case of both build and releases, is a component A related to a component B of a version, C of some other version, D of some other version. So all of this have to go together. There are 10 different components. All of them have to be built, compiled together and deployed. So these make it monolithic. In some ways, these are not independent applications, so makes it very complex to run, right? Last but not the least is monolithic thinking. You could have the most agile systems, very small components, but as an organization, as a team, if you think where everything has to move together, everything has to be built together, you're not backward compatible, you're writing code, which is sort of a legacy way to maintain, the team is thinking in a monolithic way, right? So all of this sort of defines a monolithic application, and all of this have strategies to be broken down. How do you change? In case of a build release, obviously the SRE needs to shift left, where they become part of the organization during the design, where they contribute in terms of saying, how do you scale the application? How do you build? So that the SRE mindset and an automation mindset is built way early in the development life cycle. So what are these benefits of a monolith, right? So monolith, this is how development has happened for years. I mean, since the evolution. The dev phase is obviously easy because you know the application end to end, you build it, deploy it, sort of makes it quite easy. Potentially easier to test because it's one component. You know the whole component has moved forward or backward together. So it's sort of an anti-pattern to say, yeah, testing is easy, so let's build a monolith. But yeah, it's easier from one perspective, but complex from a standpoint of, let's say, when you do a shift right, can you test things on production much more easily? If things fail in production, can you roll it back easily? Obviously, in a monolith, it doesn't work that way, right? And easier to deploy. Obviously, it's one application, you just push it in. SRE obviously is happy in doing this. In case of a microservices application, you need to know the dependencies across all the microservices. If defined well, obviously you're cross compatible, backward compatible, and all of those. And scaling of instances horizontally is obviously easy, right? I mean, you just increase the RAM, you just increase the capacity, and then obviously the application has more hardware sitting. And this was sort of the term used. If things get slow, throw more hardware at it. Typically was a good behavior of a monolithic way of working. What are the problems of the monolith, right? So no one understands the application entirely, right? So if you see what microservices based application would be, I mean, this is a fun topic that we used to discuss in the past. Would there be a director of engineering of clicking a button? Would there be a director of engineering of checkout, director of engineering of payments, right? Because those components are so small, and does that work end to end really, really well? They could be independently deployed, managed in an entirety, right? So maybe that requires to be done as an independent component. But what really happens as an organization or a set of teams, maybe it's so small, you're only focused on that area. You do not know how it works because the only way of interaction between two teams is through an API and a contract. And it becomes more of a contract-based conversation and saying, okay, I will be backward compatible and forward compatible, so I don't care. I will just deploy my code and I don't really know what your application is doing. So there could be an SRE who's stuck because that person continues to be the expert who should understand end to end and ensure the customer. I mean, I would say he or she on an SRE is a bridge between a testing and a customer, right? So the person has to ensure stability, but also has to ensure that the customer is not affected. The limited use tightly coupled, obviously it means limited reuse, I meant. So the application itself, the small component, so obviously that's harder to reuse. The only way to reuse would be extending an API and somebody consumes that API. The bit of inner sourcing is also quite tricky, because what inner sourcing means is I have built an application, I want somebody else to contribute to it, and somebody else could be internal or external to the organization. And that becomes quite complicated in the situation of microservices, because you've written such a small application for yourself. Others understanding it becomes difficult, right? And scaling, obviously, as I said, horizontal scaling was easy. Vertical scaling could be a little different, and that makes it complex. And an SRE needs to now understand a lot of different components. Earlier would be saying one build, one release cycle, and I'm done, right? In a microservices model, the SRE would be thinking is like the various different components, various different sub applications have to work together. How do you ensure scalability? How do you, the scalability of an application A versus the scalability of application B would be very different. Some might have to be horizontally scaled, some might have to be vertically scaled, some might need to have a higher DR, more resiliency, etc. Earlier, you could think one application, deploy, scale, everything together. So SRE job becomes fairly complex. And operational agility is difficult, which is what sort of I was mentioning, is SRE has to think very, very differently. Moving from one application to the other becomes quite complex as well. Then last but not the least, the tech stack keeps changing. So learning multiple different tech stacks becomes a challenge. Same for an SRE. Earlier could be one stack which has limited set of understanding of technologies. Now an SRE needs to understand how to deploy, manage .NET code versus a C# code or a Java-based code, because one application could have combinations of various different kinds of technology stacks. Sorry, just a second. My keyboard seems to have stopped. Okay, so next step would be choosing what to break. So I did mention various different ways a monolithic application could be created, and how do you make a choice on how do you break it, right? So there could be technical ways of breaking it, business ways of breaking it, and economical choices in terms of how do you break it. And what do I mean by breaking a monolithic application is to make it more agile by making more smaller kind of a independent application. Microservices is an abuse of that term, but for the convenience, let's say breaking a monolith into multiple microservices which interact with each other. There are various ways to do it, and I'll sort of cover two extreme ends of how breaking a monolithic application happens, right? So strangling and breaking, these are sort of the two extreme ends. I'll also touch upon a simple use case on two of them. Strangling is a little complex. Breaking obviously is much easier, and I will touch upon what these two are in my two use cases. So what's an idealistic approach of breaking a monolith, right? So if you see the monolithic application, there's a big set of combination of applications. There is a storage or a database which is covering all of it, and external, somebody wants to consume this monolith, you've probably built an API to cover some of these, right? So the naive approach is sort of a SOA-based approach. So you break a big monolith and make smaller monolithic applications, right? So you sort of replicate the same structure into smaller different components. Maybe you have broken the storage, maybe you have broken the different set of APIs, maybe you have broken the ownership of each of these components, but it's really not an idealistic approach, right? So the idealistic approach is sort of something that's at the bottom, which is the logical term for microservices application. You build stateless services. So you have a common set of APIs, you have a common storage potentially, but you have shared functions. And when I say a common storage, this is shared between the applications in a seamless fashion, where storage also could move, or a change on a storage could also move seamlessly based on the application, right? So you build functions, and functions interact with each other via an API. In the model here, let's say a function for A talking to a function B. will not talk to each other directly. It will talk potentially through the API layer. So if anyone else consumes, the API layer is as unique or as independent for the internal product A versus could be for an external product X, right? So this is sort of an idealistic approach. So let's take the first use case. So I will not get into the details because it's a fairly large application. So I'll take an example of a product which was a monolithic application which was doing validation, right? What validation means is any kind of a deployment would happen. It would go test the validity of that application against various parameters, not just functional, but in terms of data credibility, in terms of the way it operates, etc. And it used to do about 100 million validations per day, right? So it's not a small application. So fairly, I've simplified it as much as possible. But what has been done is there has been a core build, which is a microservice, which does sort of a validation. When I say it gives a go, no-go signal for deployment. And then there are various different APIs built to connect to it, right? How was this achieved? Taking an example, if this was a monolith, how it worked on the right, if you see, it was a big monolithic application connecting to a database. Obviously, it has all components built into that monolith, and any connectivity to this was directly to the monolithic application's app, right? What this meant, if this monolith is down, all the 100 million transactions would stop, right? Even a smaller component, even if I'm just doing one point or one small thing on that monolith, it would not work, right? So it's a very hard journey. It's not easy to start this. So you need to pick up the monolith which you believe as there is a corporate alignment to do this, and you take this and start to break. Okay, sorry, I thought somebody had a question. Okay, moving on. The next step was sort of separating the UI out of this monolith. So what we call we breaking out of the seams. So we take what are the potential components that we can pull out. UI is an easy component. So what we did here is obviously some of the interactions which happened, we would redirect it through the UI. So the UI was a separated out component. You're in this phase, you're sort of decoupling the presentation logic with the monolithic application. There could still be requests. The arrows on gray indicate there are still requests hitting the monolith, but there are new requests which are hitting the UI, right? So we are sort of starting with the easier approaches of how to break it. Then you're sort of looking at microservices. 1 second. Okay, so this, as I said, this is sort of the extension. You start building toggles, you start building flags, so that there are components within that monolithic application which you can break out. It could be one large service. I mean, if it was, let's say, application A, B, and C, try to break out a full application first. If it was one big application and within that application you wanted to break out payments, you want to break out login, you want to break out authentication, etc., that could be the other way of doing it, right? So this sort of enables that flexibility of moving. Once that's done, ensure all your requests. So the erstwhile monolith now becomes the backend service. So you route all your API requests or all your requests directly to the UI, and the UI hits the backend, right? So every conversation now becomes API based, and non-UI based application, obviously it's hitting the backend, but using the right microservices behind the scene. What this does is this migration enables you to limit the downtime. SRE gives a good amount of support, and when I say this, when all these design is happening, SRE should be involved within the design process, because if they are not, they don't understand the challenges that they would face in terms of maintenance, stability, scalability, etc. And if they are involved, they would be able to design the right APIs and also design the right applications for the organization. So once this is done, you would, let's say one of the application, let's say if it was the parser kind of a thing, which was parsing the request, if that UI was hitting multiple different applications, you sort of break it to the backend. Backend reaches the database. Parser has its own database. So you do this. And the UI, you still do not open this request, but you're sort of still the extension of the previous model. You're toggling. You could say only for one specific request, it hits the parser microservice. So you're sort of now rewriting the monolithic by breaking it down to smaller components, right? So that's what happens. And this is where an SRE plays a big role, because they are involved in terms of what needs to be enabled, how do they toggle, how do they interact with the customer or the engineering team to say when this new module can be toggled on, toggled off. And ideally, an SRE should be working in a pure GitOps model, in the sense the toggles should not be manual. The toggles also should be code-based and should be 100% automated, right? So that's the bit of the SRE evolution along with it. Once obviously this is done, focus on the API design. You're now enabling a new microservice which can be independently working with the UI, and you've sort of separated this out of the backend. And once this starts happening, the next phase is what I would call the backend now becomes backend 1, backend 2, backend 3, backend 4. So backend 1 could be a parser API, parser module. Backend 2 could be a login module. Backend 3 could be a separate module. And this eventually renames itself to a microservice. And all of them have an independent way of working with each other, right? Or sorry, independent way of working, but they can work with each other via APIs, right? So in this case, again, an SRE evolution needs to happen in terms of how do they do canary loads, how do they segment the traffic, which backend should take the load. They should be involved in the design of the gateway, on how does the API gateway work, etc. So the SRE is majorly changing the way they are operating versus how they would in a legacy versus a new age application. So eventually the new world happens. Every request or the APIs are talking to each other. The gateway is rerouting all the API requests, and you've sort of separated the database as well. And each and every service has its own recommended database or a segregation in the database where it can work, right? So this has got to a fully agile model. SREs now will have to deploy each and every service independently. Ideally, as I said, in a GitOps model where the deployment is all code-based, implementation is also code-based, right? So this is sort of the one way of breaking an application. It's in my slides. The content on the right is inspired by one of the blogs which is on the web. I have given a reference to that page, so you can read it in more detail if anyone wants to have a reference to it. The second case is very simple. I know we are just about 3 minutes to the end of this topic. The next step is very easy, is as a big bang approach. You basically build a completely API-driven, microservices-oriented application. You keep the old one on until the second application is fully built, and use one switch one day where you switch the application from the old model to the new model. So you reroute traffic completely on one switch day. Again, SRE evolution on what I spoke until now sort of remains true. The only thing that changes is the design and the implementation date is a big bang. So the day the switch happens, the SRE suddenly starts working in a new model. So learning, relearning doesn't have a long time frame in this model. So as an organization within Amadeus, the two products that I mentioned, which we moved in these two models, we are about 200 times faster. So the deployment happens, if we were doing once every 200 days, now we are doing once every day. We also have million+ pull requests, which is basically, there's a lot of inner sourcing. So I ask for a request to be done, somebody else contributes to it. Million+ pull requests is one huge thing. API-based backward compatibility, which basically is whatever we are building can be backward compatible. With all the automation in place and the SRE is doing a brilliant job, there have been zero rollbacks, which sort of helps in this process. And obviously in this whole journey, we have sort of become cloud first, DevOps oriented, etc. Right? So I'm sure with this learning, some of you should be able to do things on your own. If you are interested in the travel domain, and if you want to build applications for the travel domain, you could consume services. Developers.amadeus.com is one. There are APIs extended. You could consume these services and build up independent travel platform for yourself. with the data coming from Amadeus. So that's something, if you're a developer and SRE, you could use these services. So I'm sort of bang on time. Mr. Murthy, back to you. If there are any questions, happy to answer. I hope it was useful, and genuinely very happy to be part of this conversation, and hope to contribute.